So now let's find the equation of a line with slope negative 2/3 and passing through the point 5,4. And I want you to notice that this is exactly like the problem that we did up here. I've just changed the slope to a fraction and a different point. So it's still going to use our point slope form. So we'll use our point slope equation and we'll fill in. But I want to do one with the fraction because people always have trouble with fractions. So we'll have y minus y1, well, y minus 4. Rm is negative 2/3. And x minus, and our x1 is 5. All right, now, just like we did with the last one, we're going to distribute negative 2/3. The negative 2/3 times x is the easy part. We get negative 2/3 x. And then we want to multiply it times the 5. Now I'm going to go ahead and use my draw feature. We can think of the 5 as being over 1. So as we multiply 2/3, negative 2/3 times 5 over 1, the 2 multiplies times the 5, and the 3 multiplies times the 1. And negative times negative really gives us a positive here. So 2 times 5 is 10. And 3 times 1 is 3, so this is 10/3. All right, so our last step is take the 4 over, and I'm going to take the 4 over, and over here I'm going to add it as 4 over 1. Now, in fractions, we have to have a common denominator in order to be able to add 10/3 to 4 over 1. So we will get that common denominator. And I'm just going to do it in the prior step, but I'm going to, for the moment, write down 10/3 right here. So really, the common denominator between this 3 and this 1 is 3. I need to get 4 over 1, so it has a denominator of 3. And to do that, I just multiply it by 3 over 3, which makes 4 over the 1 the same thing as 12 over 3. So I'll bring that down here and write it right here just so it's less messy. And in my next step, I'll go ahead and add those two together. And remember, when we are adding fractions, the denominator stays the same, but we combine the numerators. So 10 plus 12 is 22 over 3. And there is our final linear equation. All right, and of course we could change that into functional notation if the question asks for it. So we could change the y into an f of x, and then the rest of this would remain the same. All right, now let's look at two exceptions here. A horizontal line, we've seen these before when we were graphing piecewise functions, are of the form y equals b, where b is some number, and they always pass through the point 0b on the y-axis. The slope of a horizontal line is 0. A vertical line is of the form x equals some number a and passes through a0. Its slope is undefined. Okay. So let's look at this question. Find the equation of the line with undefined slope and that really should say passes through 5, 4. All right, so anytime we have undefined slope or 0 slope, we are looking at either a horizontal or vertical line, and our equation is much easier to find, and we don't have to use the point slope equation. So let's go ahead and find this the easy way. Undefined slope tells us that we have an equation of the form x equals a. A is the x value in whatever point we are given. So let's notice our x value is 5. Our equation is x equals 5. Now, if this had said find the equation of the line with slope 0 passing through 5, 4, we would have had a horizontal line. It would have been of the form y equals b, and we would have looked at the y value and got y equals 4 as the equation of the line. So if we have undefined slope or a 0 slope, it's a much easier equation to find.